Digital audio workstations are software used in both home recording and professional recording studios. This software forms a core part of music production, and today we'll cover everything a DAW can do and how they've solidified their place in the recording studio. In the modern home recording studio, the DAW and the computer that runs it is the center of all music production that every piece of equipment and idea runs through on its way to becoming your next song. The digital audio workstation connects to our music recording equipment, like MIDI controllers like keyboards and drums, and audio interfaces, which lets us access external microphones, preamps, audio processors, and gives us outputs through headphones or monitor speakers. In general, a DAW is meant to be a home recording studio in a box, meaning it replaces a lot of hardware that was previously required. For many users, the DAW replaces almost all the recording equipment with tools for audio recording and editing, mixing with Virtual Console, and electronic music production with MIDI using sampled and synthesized instruments. Audio recording. Audio recording in a digital audio workstation is fairly straightforward. In a recording studio, audio is captured by a microphone or created by another instrument and enters a digital audio interface. Here it's converted from an analog signal to a digital signal with a sample rate and bit depth. The digital audio is then recorded on a track in the digital audio workstation for editing and processing. All digital audio workstations should allow at least some degree of multi-track recording, meaning they can capture multiple audio signals on different tracks all at once. Audio recording works by telling the DAW what inputs from your audio device to capture and arming a track to record, so the DAW records on the specified track when the project is in record mode. Depending on the DAW, you may have additional options for loop recording and comping, which allows recording of multiple takes and selecting the best parts of each take during editing. Nondestructive editing. All digital audio workstations today work on the basis of nondestructive editing. This means that all our audio tracks are initially recorded and that file is not modified further by the edits such as trimming and applying plugins. We can rearrange these clips as much as needed and go back later and easily undo the changes without losing any of that data or having to re-record a track. MIDI recording, piano roll, and quantization. Though not a strict requirement to define a digital audio workstation, basically all of them available today have some form of MIDI capability. MIDI is a protocol that sends signals with note values, velocities, and timing and duration from different devices such as a keyboard or drum trigger pad to a virtual instrument in software or a hardware synthesizer. Digital audio workstations feature MIDI and instrument tracks to save these files and play them through a synthesizer, and a piano roll view with a timeline along the top, note values on the side, and all the notes to be able to edit the MIDI. Quantization is another tool included in most DAWs, which automates the timing correction of all the MIDI notes and helps snap them to the grid to make them sound more on time. Virtual instruments. Most digital audio workstations will include some basic virtual instruments to create sounds with MIDI, or will allow additional third-party instruments to be added to the program. Virtual instruments are very variable as far as how they work and what capabilities and quality they have. There are some very simple free instruments or paid sampling instruments that can closely replicate expensive high-end instruments that can cost hundreds to thousands of dollars. Mixing console. The mixing console in a digital audio workstation is designed to create a similar workflow to a hardware mixing console in a recording studio. DAW consoles have a signal flow that goes from top to bottom, starting with the audio inputs at the top, followed by inserts which are used to process inline effects, sends which group a set of different tracks together to be processed by an effect, and then the mixing tools which usually include solo, mute, and record arming tools. Muting disables the track so it's not heard. Soloing a track makes it so all the tracks with the solo button pressed play, while the ones that are not solo do not play. Record arm is used to tell the software which tracks to record so it doesn't record all the tracks when we start recording. After that, we'll often have an input monitoring button that lets us hear the process signal with all our effects while we're playing the instrument or recording. At the bottom of all the tracks on the mixing console, we'll always have a pan knob that helps position it left to right in stereo space, and a fader that adjusts the volume of that track. Digital audio workstations have multiple included effects that can process our audio signal. Basic included effects are compression, which helps change the dynamics and volume of our audio tracks based on timing, ratio, and threshold parameters, and equalization, which is used to adjust the volume levels of different frequencies. We usually will get modulation effects like chorus and delays as well. Reverb effects are used to simulate a room sound instead of a dry signal. Audio effects in a digital audio workstation are added as plugins, which can be VST, AAX, or AU plugin format depending on which digital audio workstation and operating system you're using, with AAX being specific to Pro Tools and AU being used on macOS. These plugins replace hardware processors that high-end recording studios would use in a rack unit as analog or digital audio processors, and do all this processing completely within the digital audio workstation. Signal routing within a digital audio workstation works like it would on a standard mixing console, meaning an effect or plugin can be processed as either an insert on an individual track or as a send. For an insert, there's an effect with an input and output, and the entire signal chain goes through it with a completely processed signal coming out from the output. An insert can process one track at a time. If this were being done with hardware, we would need a separate audio processor for each track that we wanted to apply the effect on. In comparison, a send has different signal routing. We can think of the signal for a send as being split. One signal is sent down the original signal path without being processed and goes to the master channel. A second identical signal is split off and sent to an aux track. The aux track can then receive multiple signals and blend them together at different levels than they would be sent to the master channel. This means that if I have a guitar track and a drum track, I can make the guitar louder than the drums with a clean signal, but add less effect to the guitar sound in the send. We also don't need to send all our tracks for processing at this send, so if we don't want the bass processed, we can just leave it out. From the receiving channel, all our tracks will be processed together through a single signal processor. Sends are often used to apply effects such as reverb. With the send, all our reverb for all our tracks will sound consistent, and we can adjust the level or mute the reverb for all tracks at once. From the days of analog audio processing, sends also helped cut down on the number of audio rack processors a studio needed, since multiple tracks can be processed simultaneously. Automation. Automation controls allow us to program changes to track and effect settings throughout a song. We can adjust things like volume, muting, panning, and effects controls. Automation applies these changes consistently and predictably with each playback, and also allows these changes to be exported with our final track. Automation is often programmed by writing it out with the mouse with a set of point markers of different levels or values along the timeline, or can be recorded from a MIDI controller like my AKAI MPK 249 that I use on my projects. Master channel. All the audio created, edited, and processed in a digital audio workstation goes through the master channel as the last step before being sent to the audio interface to play back through our headphones or monitor speakers. The master channel works very similar to an audio track, meaning that we can process the entire signal together and apply effects. We can still add effects like compression and limiters, stereo spacing processors, or other mastering effects here. This is also the place where we can listen to our entire project with the mono button to hear any frequency interference, or use a frequency spectrum analyzer on the project. Exporting. At the end of every project, digital audio workstations give us exporting tools to get our music from the software to a file we can distribute and share, often with lots of options for file type, compression, and other settings. In summary, digital audio workstations are essential to the home and professional recording studio environment. What was previously done with thousands of dollars of equipment in specialized spaces can be accomplished within a single computer. DAWs are capable of replacing a lot of equipment such as analog and digital audio recorders, mixing consoles, signal processors, synthesizers, and more. To effectively use a DAW, all you need is a computer, audio interface, instruments and microphones if wanted, and a monitoring setup such as headphones or speakers. Thanks for checking out this video on what digital audio workstations are. If this video helped you out, don't forget to give the video a like, subscribe to the channel, and press the bell icon to be notified whenever a new video is released. You can also check the video description for links to social media accounts to stay up to date on all our new content.